JDK 17 introduced a new modifier, sealed for classes and interfaces. This modifier can be used for both outer types and nested types. When used, a permits clause is also required in most cases, which lists the allowed subclasses. Subclasses can be nested classes, classes declared in the same file, classes in the same package, or if using Java's modules in the same module. I'll be covering Java's modules later in the course. What this means though for this specific conversation is that all our code so far since JDK 9 is part of what's called the unnamed default module. Because of this, I can't use subclasses in the permits clause that are in other packages. A sealed class and its direct subclasses create a circular reference. I'll be explaining what that means shortly. I want to go back to the game class in the game console project I've been using. I'll add the modifier sealed on the game class. IntelliJ doesn't like that change. Hovering over that, I get the message, sealed class permits clause must contain all subclasses. I have two subclasses already, shooter game and pirate game, so I'll add a permits clause manually and include both of those. The permits clause should be the last clause of the class declaration, listed after any extends or implements clauses. I've got errors though, one on pirate game and one on the shooter game in this clause. If I hover over pirate game, I get the message, class is not allowed to extend sealed class from another package. Our pirate game class is in the pirate package, so this isn't permitted, but shooter game is in the same package as game, so let's see what that error says. I'll hover over that. This message tells me that all sealed class subclasses must either be final, sealed or non-sealed. Actually, if I try to run my main file main method here, I get the compiler error that is a bit more enlightening, that the code is all in the unnamed module. If I'm going to use the sealed class functionality, I have to do it for a class in the same package as game. This message confirms that our code is in an unnamed module, as I mentioned on the first slide. Before I continue, I'm going to copy my game class and create a new class from that, also in the game package. I want to call the copy sealed game. I'll go back to the original game class and undo the last changes, removing the sealed modifier and the permits clause. Now going to my new sealed game class, I'll first remove the pirate game from the permits clause. Because pirate game is in another package, I can't include it here. I can include the shooter game, but first I need to change the declaration to extend the sealed game and not game. When I do that, I get the error sealed, non-sealed or final modifiers expected. IntelliJ is suggesting I make shooter game final, so I'll do that. This clears up my errors for the shooter game and sealed game. You can't make a class sealed without first adding a modifier to a subclass if you haven't already included one of the three valid ones. Are you confused by these interdependencies? Let me show you a couple of slides which will try to clear up what just happened and show you the big picture. Using the sealed keyword requires the parent class to declare its subclasses using a permits clause. This means the parent class has to know about every direct subclass, and these have to exist in the same package in this case. In addition, the sealed keyword puts a requirement on all the subclasses that were declared in the permits clause. It requires each subclass to declare one of the three valid modifiers for a class extending a sealed class. These are final, sealed or non-sealed. On this slide I have a parent class X declared as a sealed class and permitting only classes A, B and C to subclass it. For that reason class D, which may exist and extends X, won't compile. You'll have to either add D to the permits clause on X or remove D from the hierarchy in some way. As I've stated several times, all subclasses declared in the permits clause must be declared as final, sealed or non-sealed. Declaring a class final means no other subclasses can extend that class, as I show with class A on this slide. A subclass declared with a sealed modifier, shown here with class B, must in turn use a permits clause. Its subclasses in turn have to use one of the three valid modifiers. Lastly, a subclass can use the non-sealed modifier, as shown with class C. This means it's basically unsealing itself for all its subclasses. This one at first sounds like a bit of a mystery. Why would you allow subclasses to unseal what you said should be sealed. We'll look at each of these in turn. I think the scenario I've currently set up is the easiest to understand. Basically, I'm allowing a few classes in the same package to extend our special sealed game, and that's where the subclassing stops. I'm going to go to my shooter game and revert it so that it again extends the unsealed game class. I will leave the final modifier there. Next, I'll just delete the sealed game class. I'll create a new class in a dev.lpa.sealed package, calling it Special Abstract Class. I'll add the sealed and abstract modifiers to this class. And right away, I'm in a position where it's expected that I'll know what my subclasses are, and I need to declare them for this sealed class. Before I add any subclasses in this package, I want to first include a nested class. I'll declare a class called Kid here, and I'll have that extend the outer class, the Special Abstract class. I get an error on the Kid declaration with the message that Kid has to be declared as sealed, non-sealed, or final. So I'll make that final here. Now this code compiles, but why is that? I haven't included a permits clause, so why is this okay? Well, there's one exception where we don't have to declare a permits clause, and that's if all your subclasses are nested classes. You can optionally still include it. I'll add it here and specify Kid in the clause. But that's giving me an error, cannot resolve symbol Kid. As it turns out, when you use a subclass in a permits clause, you have to use the qualifying name, meaning you have to qualify it with the outer class name, which I'll do now. I'll reference Kid as specialabstractclass.kid. Now this compiles and all is well. Next I'll create the 3 different flavors of subclasses external to this class next. First, I'll create a final Kid class in the same package, so in dev.lpa.sealed. I'll include the final modifier and have it extend the Special Abstract class. For now, that's not going to compile until I add this class to the permits clause on Special Abstract class, which I'll do shortly. I'll create the other 2 classes first. Next will be sealed Kid. I'll add the sealed modifier on this one and have it extend Special Abstract class. The last one will be called non-sealed Kid. I'll add the non-sealed modifier and again extend the Special Abstract class. Okay, so I'll now go add these 3 to the permits clause on Special Abstract class. If I hover over that error on the class name, IntelliJ gives me the options to add missing subclasses to the permits clause. I'll then add a new line after the comma here, so you can see the entire declaration. Notice that I have an error on sealed Kid because it's sealed. I have to specify a permits clause on that class. I'll go to the sealed Kid class. Instead of adding a permits clause here, I'll add a nested class grandkid. I'll make the class final and have it extend sealed Kid. If I go back to the Special Abstract class, let's see what happens if I now try to remove this class's nested class from the permits clause. I'll do that now. Actually, I can't do that now. Omitting the permits clause or a class from the clause only works if you don't have other non-nested classes extending this sealed class. These rules seem complicated, but the main thing to remember is there's a circular relationship between a sealed class and its subclasses. A sealed class has to have knowledge of its subclasses, which an unsealed class doesn't. An unsealed class can have many unknown subclasses. I'll undo that last change. Maybe you noticed that I didn't have to declare grandkid in this clause. Only direct subclasses are required to be named in the permits clause. The last thing it would be nice to understand about sealed classes is this business about allowing a non-sealed subclass. Let's create one more class, free grandkid. I'll have this extend the non-sealed kid. This is allowed. That seems kind of weird, doesn't it? Let's see if we can figure out why Java allowed this. First of all, there's probably always an exception to every rule, and often these exceptions are discovered very late. Having the ability to change a subclass to non-sealed is a way to control a branch of your hierarchy. Remember, the subclass has to either be part of your own package or module. This means that when you permit a non-sealed class, you're making a very conscious decision to to allow extensibility for that specific branch. When would you do this? I guess I could come up with a couple of use cases if I tried hard enough. Maybe you might allow a trusted vendor access to this non-sealed branch. This would enable them to include value adds on top of your base set of widgets. You could provide the non-sealed class situationally. Before I end this video, I need to talk about sealed interfaces. Like a class, you can seal an interface, specifying who gets to implement your interface. I'll create a sealed interface called sealed interface in the sealed package. I'll add a single abstract method, which will take a predicate functional interface for a string and a variable argument with strings. This method could be used to test some kind of relationship for a set of strings. I'll create a class that implements this, and I'll call that string checker again in the same package. I'll add the implement sealed interface to the class declaration. I'll implement the method using IntelliJ's tools. That's all I need for my purposes. I'll also extend my sealed interface with a better interface. That will extend sealed interface. Now I'll seal my sealed interface, adding the sealed keyword. I'll hover over that and select the link in that pop-up to add missing subclasses. Now notice it added a permits clause, and here it has the interface that extends sealed interface. That's better interface, but it also has my string checker class that implements the sealed interface. Similarly to a sealed class, I have to go back to both those types and decide if they're final, sealed, or non-sealed. For an interface, the final modifier isn't valid. An interface, by its nature, is a contract of abstracted methods. For the better interface, I can only choose between sealed or non-sealed. I'll go with non-sealed here for simplicity's sake. For the class that implements sealed interface, I have all three options. I'll go to my string checker class and make that final. Okay, so that's one of Java's newer features. I've demonstrated in this section of the course that extensibility might inadvertently expose your code to problematic subclasses. This access could provide access to the internal state of your objects, leading to intentional or unintentional mutability. Using sealed types gives you another level of control by allowing you to choose which types can leverage your code. This video ends the section on immutability, but I have one last challenge for you. I'll be again visiting the pirate game for this, so I hope you'll find it fun, and I'll see you in the next video.